So this is where we ended. 162 divided by 3. And it's a cubic. So 162 divided by 3. Sorry, I got interrupted before. So I can rewrite this one as cubic root 162 divided by 3 is 54. And then on bottom, cubic root was 1. Looking at my y's here, there are more y's on top. So that'd be y cubed. And then y's on bottom. I should see if I can simplify 54 even further. So 9 times 6, 3 times 3, 3 times 2. So now I have a group of 3's, 3 3's. So I rewrite this. The cubic root of 1 is 1. Now I will have the cubic root still left over because this 2 still has to stay in your cubic root. So I have 3. Cubic root of y cubed is just y, because you could do 3 divided by 3 and get the 1. Then I'm left with my cubic root of 2. Now that's over 1, but you don't really have to have that 1 there. You can just leave it just like that. You should try C by yourself. I realize you can see through the post-its. Pause and try C by yourself. And we have here. So you can simplify the equation first. You don't have to rewrite it like this. These two are kind of like the same thing. So I have the square root of 25x squared once I simplify my fraction, and I just get x or 5x. So what if I can't simplify the fraction? What happens then, Ms. Frickman? Well, you have to rationalize the denominator, meaning that you do not want a root in the denominator. The reason why we do that is just improper. So that it's easier to tell if you can combine like terms. Essentially, that's the whole reason why we rationalize the denominator, meaning there should not be any radicals in the denominator. So first you want to look at your index here. My index here is 2, so I need to have a group of 2 to simplify that. I'm going to multiply this essentially by 1. So whatever is on top has to be also on the bottom. So I look at the bottom because that's where I want to get the root out of. I'm going to multiply that by square root 3. Whatever is on bottom, I have to multiply by on top. So on top, 2 square root 3 over square root 3 times square root 3 will give me square root 9. Now, once you do this step, this should be able to simplify. So in this case, we have 2 square root 3 over square root 9 is 3. So that would be rationalized. I want you to try the second one right here by yourself. So pause, try it, check it with mine. Here we go. Now, before there's 2 ways that you could do this. So you could multiply by this bottom part, square root 6x, and you get this, but then you have to make sure that you simplify this. So the square root of 18 is the same thing as the square root of 9 times square root of 2. You could also do your factor tree there to get 9 times 2, and then 3 and 3 and get the pair of 3's. And then you can simplify this fraction once you simplify the square root of 36 and x squared. That's one way. Or I kind of did what I did up here with rationalizing. So first, I simplified the fraction. This fraction was simplified to 1, square root of 1 over the square root of 2x. So right here, I just multiplied by square root of 2x times square root of 2x. So it's the same on top and bottom. So essentially I have, this is the same thing as 1, square root of 2x over square root of 4x squared, leaving with 2x squared, the square root of 2x over 2x. That's a lot of 2x's. Same thing, just a different format. Here I simplified after I rationalized the root. Here I simplified before. So looking here, now again I'm looking at the bottom of my fraction. I want to rationalize this square root 5. I don't have to do anything with that 2. That 2 is completely fine down there. I'm going like this, so it's like. So I'm going to multiply just by the square root 5 over the square root of 5. Because that's essentially the only thing I want to get rid of. So on top, I would have multiply across. I have 5 square root 5. On bottom, this 2 would be like if there's a 1 there, you don't need to have that. But that 2 is still out in front. And then square root 5 times square root 5 is square root 25. I do realize that some people can do this pot in their head, and some people just jump to this answer. So 2 square root of 5 is 5. So this right here would give me 10. Now this is where you can keep on keeping on, because now since there's no root, I can look at these two whole numbers, just like if I had 5/10. I can look at that 5 divided by 10 is going to give me 1/2. So I have square root 5 over 2. That would be my final answer for that one. So I want you to pause the video and try that very last one by yourself. Pause, unpause. So now this one's a little bit more tricky because look at my index here is 3. So that means I have to have a group of 3. Now, I wrote down 2 more 2's because I need to have a group of 3. So it's the cubic root of 2 times 2. I could also have written it as the cubic root of 2 squared or the cubic root of just 4. So I multiply across, I get x, cubic root of 4 because 2 times 2 is 4. On bottom, I get the cubic root of 2 times 2 times 2 is 8. So if I simplify this, then I have 2. And that's my final answer. Switch. Next. So we're going to start with A. Oh my gosh, this looks a lot more complicated, but it's not. First, I look to see, can I simplify this anywhere? No, I can't. However, I am going to look at 12. I'm going to rewrite 12. So this is the cubic root of 5x squared. And I'm going to rewrite 12 as imperfect squares. 4 times 3, 2 times 2. So I have 2 squared times 3, y squared times z. So I didn't actually do anything. All I did was rewrite this 12 as 2 squared times 3. The reason why I'm doing that, because now I'm going to multiply so I can rationalize the denominator. So again, it's always looking at the bottom. I'm looking at the bottom here. So whatever is the cubic root on the bottom is the same cubic root that I'm going to multiply on top. So I'm looking for groups of 3. Right now, I already have 2 2's. So to make a group of 3, I need 1 more 2. Looking at my 3's, I have 1 3. I need a group of 3 though. So if I need a group of 3, I have 1. I need 2 more. For my y's, I have 2 y's. I need 1 more y. Remember, whatever's on bottom, same thing you multiply on top. And z's, I have 1 z. I need 2 more z's. Like so. And I multiply across. So this essentially is 2 times 9, because 3 squared is 9. So if you want to think about this, you can type that all in your calculator. 9 times 2 is, actually I'm going to do 5 times 2 is 10, times 9 is 90. So I have the cubic root. This becomes 90. X squared, y, z squared. There's nothing that can combine there right now. For on bottom, because this is what I want to rationalize, I'm going to rewrite this as the cubic root, and then I'm going to keep it in exponential form. So my base here is 2. I have 2, 3. My base here is 3. I have 1, 2, 3. My base here is y. I have 2, 3. My base here is z. I have 1, 2, 3. And the only reason I did that is so I can make sure that I multiplied this by the correct number, because now all of these have a group of 3 with it. So on top, if you could, you should simplify this, but I know that I only have 1 5, 1 2, and 2 3s. I don't have a group of 3 there anywhere. So this is going to remain as the cubic root of 90, x squared, y, z squared. And on bottom, when I take the cubic root of each of these, I'm left with 2 times 3, y, z. So 2 times 3 is 6. One thing to be aware of is that you cannot simplify in the root without a root. I can't do anything with that 90 and that 6. That's my final answer. Looking at my next group here. So here again, I'm looking for my cubic. Remember that whatever cubic is on bottom, same cubic on top. So I have 1 5. So I need 2 more 5s, so 5 squared. 2 5s. I have 2 y's, so okay, I need 1 more y to make a group of 3. So I multiply across, so this is 5 squared is going to give me 25, 25, 25 times 7, or how many quarters is 7 quarters is 175. So cubic root 175. I have this x still when I'm multiplying across, and I have this 1y. Cubic root, I have 1 5 here, 2 here, so this would be 5 to the third. I have 2 y's, 1 y, this would be 5 to the third. I do realize, and I am okay with, as long as I can clearly see your work, if you would go from this step to this step. Bing, bada, boom. You should pause the video and try to do C by yourself. Okay, one thing, look it. I was about to do this really complicated, like right above here. But then I was like, wait a second, Mrs. Frickman, that's silly. Before I do anything, I should look to see if I can simplify my fraction. Let's say if I didn't do that, if I didn't simplify my fraction, I went all the way through this, at the very end, I should still get this. It's just going to show me a lot more work. I would have to simplify a lot more throughout the process. But both are index 3. 15 divided by 5 would give me a 3 on top. X squared over x gives me x. And then all this would cancel, so it's the cubic root of 1. The cubic root of 1 is 1, so that's it. So I don't have to do anything else. If you didn't already try to do D, pause, do D. Unpause. So here again, I'm looking at, can I simplify this fraction first? 21 divided by 7 is 3. X to the 10th divided by x to the 5th is going to be x to the 5th on top. And when I'm looking at this, if you leave your answer like this would be incorrect, because I can still simplify the square root of x to the 5th. There are 2 groups. So x to the 5th, there are 2 groups of 2 there, and 1 left over. So there's my answer. And there we have it. There's all 6.2 in all of its glory. And I hope you have a great day. Bye.